I'm Anil Kumar, and here is a linear quadratic systems equation which we will solve with the help of inequalities. Question here is, determine the maximum value of k such that the linear function g of x equals to 3x plus k is not greater than the quadratic function f of x equals to 2x squared minus 5x plus 3. So try to uh, pause the video and solve the question and then look into my solution. Now let's first try to understand this equation. It says we need to find maximum value of k such that the linear function 3x plus k is not greater than, that means it has to be less than the quadratic function. Okay, so quadratic function is a parabola kind of like this which opens upwards. So that is the quadratic function. We are not making any scale. And the linear function is a line. It's kind of a line like this. Is it okay? So that is the linear function we are talking about. Now, when we say determine the maximum value of k, we know the slope. K will move it up or down, right? So that's the y-intercept. So this line could be kind of like this. Even then, line is lower, but it could be kind of like this, tangent to our function. So that means we are basically looking for a line which is tangent to the function. Tangent here will mean that they have only one point of intersection. Do you understand? So that gives us a clue to get the answer. So we have to find the value of k so that this system has one solution. So that means find k for one solution to given system, right? That is the question, to given system, which is linear quadratic, correct? So what I'm trying to say here is, it really means that we should try to find the value of f of x equals to g of x and ensure that we have one real solution. Do you understand now? So that is the question. So let's find it. So we have f of x as 2x squared minus 5x plus 3 and g of x is 3x plus k. So bringing them together, we are trying to find this equation and ensure that it has only one solution. Let's bring them together. So we have 2x squared minus 5x, bringing 3x to the left side becomes minus 3x, and then we have 3 plus k equals to 0. Combine these two, so we have 2x squared minus 8x plus 3 plus k equals to 0. Now when we say one solution, it means what? It means we are looking for the discriminant b squared minus 4ac to be equal to 0. That's the key issue, right? And in this particular equation, a is equals to 2, b is equals to minus 8, and c equals to 3 plus k, correct? Using these values, let us solve for b square minus 4ac. Okay, so let's solve for b square minus 4ac. So we'll solve for b square minus 4ac. b is minus 8, so minus 8 square minus 4 times a is 2, and c is 3 plus k. And that should be equal to 0. So that is what is required. So that is 64 minus, this is 8 times 3 plus k equals to 0, right? Oh, I'm sorry, when I brought it this time, k should be negative, right? K should be, good, I found this. Okay, let me do this correction. K should be negative. I'm sorry for that. So when you bring it to the left, 3 is minus, I do, k should be negative, right? So this k should be negative. Okay, 3 minus k. Good time to find the error. So what we get here is 64 minus 8 times 3 is 24. Minus minus becomes plus. 8k equals to 0. Now 64 minus 24 is how much? 4 take away 4 is 0. And then we get 40. 1 plus 8k, right? Equals to 0. And now we can say 8k equals to minus 40. Or k equals to minus 40 over 8, which is minus 5, right? So we have our solution, and that is k should be equals to minus 5 only then f of x and g of x will have this situation. It will be tangent and the line is not greater than, right? It could be equal to. Do you understand? Not greater than means not greater than means what? It means less than and equal to, like this. Do you understand? Less than and equal to. And that's why we took this position of a tangent, right? So we get our solution that k should be equals to -5, correct? So that is how we can solve this question. So we started with that maximum value of k such that linear function is not greater than, that means we started for gx is not greater than f of x, right? That means g of x is less than equal to f of x, and that's why tangent was critical. Maximum value of k will be -5. If I take k as more than -5, the line will cross at more than one point and it will be greater than the parabola at least during some interval, correct? So I hope you understand the concept. This really is a tricky questions to answer. I hope that helps. Thank you and all the best.